Strontium-90. Kind of sounds like something out of a sci-fi flick, doesn't it? Radioactive, nuclear fallout, the whole shebang. Gives you the chills just thinking about it.
Definitely got that ominous ring to it.
Right. But here's the thing I find. While Strontium-90, it's like this tiny piece of a much bigger puzzle. All goes back to this element, strontium, and get this, it's in all sorts of stuff. Fireworks, even toothpaste. Seriously, who knew? So today, we're going deep on strontium, where it comes from, what we do with it, and why it's way more interesting than you probably think.
It's a pretty fascinating journey, that's for sure. You've got this element that starts off in a sleepy Scottish village and ends up playing a part in some really cutting-edge technology.
Yeah, no kidding. And it even helps us uncover secrets from the past, right? I gotta admit, I did a little digging before this, and honestly, I was blown away. So let's start with the basics. Strontium, what is it? Where do we find it? Don't tell me they just, like, dig it up out of the ground somewhere.
Well, you're not entirely wrong. It is found naturally, but our story starts a long way from a high-tech lab. Picture the Scottish Highlands, late 1700s.
Okay, I'm picturing it. Lots of fog, probably some bagpipes in the distance.
Maybe. But in this case, there's also a group of miners hard at work in a lead mine near a village called, you guessed it, Strontian.
Wait, hold up. They found strontium in a lead mine. Seems like a weird place to find a new element.
You'd think so, right? But that's often how these scientific breakthroughs happen, pure chance, a case of mistaken identity. Turns out, at first, they thought they'd stumbled on some kind of barium compound.
Barium, that's another element, right?
Exactly. Fairly well known back then. But there was this Irish chemist, Adair Crawford Sharp guy, and he noticed that this stuff they'd dug up, it wasn't quite behaving the way barium should.
Interesting. So he's looking at this thing thinking, something's not adding up here. What was it? Like a different color? Did it smell funny?
It was more about the mineral's properties. They just weren't quite lining up with what he knew about barium. And then, a few years down the line, another chemist, Thomas Charles Hope, he confirmed it. Yep, brand new element. He even noticed that it turned a candle flame a brilliant red.
So like a signal flare. That's kind of cool.
Exactly. It was an early example of something called a flame test, which is still used to identify different elements.
Huh, who knew fire could be so scientific? Okay, so now we've got this mystery mineral, a bunch of excited scientists, and a whole lot of questions. But how do you even begin to study a brand new element, especially back then?
That's where a scientific superstar enters the picture. Humphrey Davy. Remember him? Electrolysis, isolating potassium, sodium.
Vaguely. Wasn't that splitting atoms or something?
Not quite splitting atoms, but close. Electrolysis uses electricity to break down compounds into their basic elements. And in 1808, Davy used this technique to isolate pure strontium for the very first time.
Wow, so he basically zapped it into existence.
In a way, yeah. And what he found was a soft, silvery white metal, the pure element of strontium.
Humphrey Davy, what a legend. Isolating strontium, that's huge. What did they even do with it? I mean, besides fireworks, obviously.
You're right. Fireworks are probably what strontium is most known for. Those brilliant reds you see exploding across the sky, that's strontium salts at work.
Right. It's like the quintessential firework color, but there's got to be more to strontium than just pyrotechnics.
Oh, absolutely. You remember those old school color TVs, the really big, bulky ones with the cathode ray tubes?
Oh, yeah. My parents had one when I was a kid. It was practically an antique. I remember my mom always telling me not to sit too close, something about radiation.
Exactly. Cathode ray tubes did emit small amounts of X-rays, and that's where strontium comes in. Strontium carbonate was actually used in the glass of those old TV screens.
Wait, really? Strontium and X-rays? What's the connection?
Strontium carbonate is really good at absorbing X-rays. So in those old TVs, it acted like a shield, protecting viewers from unnecessary radiation exposure.
Get out of here. So strontium was like this unsung hero of television for decades. That's pretty cool. But you know what else is cool? That whole time-traveling element thing our research mentioned. What was that about?
Right. Well, it all comes down to strontium's similarity to calcium.
Okay, yeah, calcium. I remember us talking about that earlier. But how does that make strontium some kind of time-traveling detective?
So, because strontium is so similar to calcium, living things, plants, animals, us, we all absorb it, right? And get this, when strontium gets into our bones and teeth, it kind of stays there. It leaves behind this unique signature that can tell us a lot about where a person or animal lived.
Hold on, a signature? What do you mean? Like a chemical signature?
Basically. You see, different geographical locations, they all have slightly different ratios of strontium isotopes in their environment. It's all about the rocks, the soil, the water. Think of it like a fingerprint for a place.
So, like, one place might have a slightly different strontium flavor than another?
Precisely. And when an organism absorbs strontium by drinking water or eating plants from that area, its bones and teeth, they absorb those specific strontium ratios. It's like a geographical fingerprint.
Whoa, that's pretty incredible. So you're saying by analyzing the strontium in, say, an ancient skeleton, we can actually pinpoint where that person lived.
You got it. It's pretty amazing. We can trace ancient migrations, learn about the diets of people who lived thousands of years ago, all thanks to strontium.
That's like having a GPS for the past. Strontium, the archaeologist's secret weapon. This is all blowing my mind, but there's got to be a but coming, right? It can't all be sunshine and roses.
You're catching on. Everything we've talked about so far is about natural strontium, which is pretty harmless. But there's another form of strontium, strontium-90. Remember how we said it had a bit of a darker side?
Strontium-90, yeah, that's the one that gives me the heebie-jeebies. Why is that? What makes it so different? Strontium-90, dark side. Lay it on me.
Well, strontium-90, unlike those naturally occurring forms we talked about, it's radioactive.
Yeah, that's what I figured. And radioactive means what? Basically bad news.
Pretty much. We're talking about a byproduct of nuclear fission here.
Nuclear fission, that's like nuclear reactors, atomic bombs, that sort of thing.
You got it. It's one of the big concerns with nuclear fallout, actually.
So yeah, not something you want to be around, I'm guessing?
Definitely not. And here's the thing. Strontium-90, it's got a half-life of around 29 years.
A half-life, meaning it takes that long to basically disappear?
Not exactly disappear. A half-life means it takes that amount of time for half of it to decay into something less radioactive. So it can actually stick around in the environment for a really, really long time.
Wow. Okay, so it decays, but if it's still around, what makes it so dangerous?
It's the radiation it gives off while it's decaying. And remember how we were talking about strontium being so similar to calcium?
Oh boy. Yeah, I have a feeling I know where this is going.
Well, just like with calcium, your body can absorb strontium-90. It basically can't tell the difference, so it ends up right in your bones, your teeth, places like that.
Hold on, so now we're talking about radioactive material hanging out in your skeleton. That can't be good.
Not good at all. Because it's in your bones, strontium-90 keeps giving off radiation. And that can cause some serious damage. We're talking bone marrow damage, increased risk of certain cancers, the works.
Okay, wow. Yeah, that took a turn. So with all that scary stuff, is there any reason we'd ever actually want to use strontium-90? Don't tell me it's in glow-in-the-dark toys or something.
No, definitely not in anything like that. But believe it or not, in very, very controlled settings, there are some uses for strontium-90. We're mainly talking medical and industrial applications.
Seriously, how can something so dangerous actually be, like, helpful?
One example is something called radioisotope thermoelectric generators, or RTGs. They're basically like nuclear batteries.
Nuclear batteries. Okay, now I have to hear more about this. How does that even work?
So they use the heat given off by radioactive decay, like from strontium-90, to generate electricity. And because they last so long, they're perfect for things like space probes, deep-sea equipment, anything you can't just plug in and recharge.
Wow, that's incredible. So we're talking strontium-90, this potentially harmful element powering things in outer space. It's like something right out of Star Trek.
It really is. It just goes to show you, sometimes even the things that seem dangerous can have surprising uses.
This whole deep dive has been full of surprises. We started with fireworks, then those old TVs, ancient migration patterns, and now nuclear batteries. Who knew strontium had it in it?
It just goes to show you the periodic table, it's more than just a chart on a classroom wall. Each one of those elements has this whole story behind it, this whole world of possibilities.
Absolutely. And who knows what we might discover about strontium in the future? Maybe it holds the key to some other scientific breakthrough we haven't even imagined yet.
Exactly. That's what's so exciting about science. There's always more to learn, more to uncover. Even an element like strontium, one we think we know, can still surprise us.
Well said. So next time you see a burst of red in a fireworks display, maybe take a second to think about strontium and its amazing journey. From a little village in Scotland to the frontiers of science and technology, you might just see the world in a whole new light.